Welcome to the video for lesson 1.4 on independence. Two events are called independent if knowing the outcome of one event does not influence the probability that the other event will occur. So more A and B are independent. This means if the probability of A given that B happens is the same as the probability that A would happen anyway, knowing that B happened doesn't change anything. And the probability of B given A is going to be equal to the probability of B because knowing that A happens doesn't change the probability of B. And recall that the multiplicative rule told us that the probability of A and B, intersected with B, is equal to the probability of A times the probability of B given A. So when we have independent events, that means the probability of A intersect B is equal to the probability of A times the probability of B, only if we have independent events. Let's look at some examples of independent events or not independent events. So recall our example from our last video where we were looking at the probability of being Democrat given that a senator was male, was 0.463. The probability of being a Democrat given that a senator was not male was 0.80. So here, knowing whether or not the senator is male changes the probability that they're a Democrat. So these are a situation where the events are not independent of each other. Information about whether or not the senator is male changes the probability that they're Democrat. These are not independent, and we call not independent events dependent events. So here we go. These two events are D and M are dependent. When things are not independent, we call them dependent. Let's look at another example. If we are going to randomly select a card from a deck of 52, there are 13 hearts in the deck. So the probability of selecting a heart is 13 out of 52. The probability of selecting a queen, there are 4 queens, so there are 4 out of 52 that are queens. The probability of picking a card that is a queen intersected with a heart, that means it's a queen and a heart, there's only one, it's the Queen of Hearts, 1 card out of 52. Now let's look, if we multiplied the probability of a heart times the probability of a queen, that's 13 out of 52, times 4 out of 52, which gives us 52 divided by 52 times 52. If I cancel these out, this gives me 1 out of 52. So I can see that the probability of being a queen and a heart, intersecting with a heart, is equal to the probability of a heart multiplied by the probability of a queen. And this will be true if and only if the events are independent. So let's just take one more look. So we saw last time that the probability of a heart on our last slide. Probability of a heart is 13 out of 52. The probability of a heart, given that it's a queen, is 1 out of 4. And if we reduce our 13 out of 52, it's 1/4 or 0.25. And these two are equal. So we can see that knowing that we have a queen does not change the probability of having a heart. That means we have independent events. Similarly, probability of a queen was 4 out of 52, which is equal to 1 out of 13. the probability of having a queen if it's a heart. We've got 1 queen of hearts divided by the total number of hearts, 13. So we can see here that knowing whether or not we have a heart does not change the probability that the card will be a queen. So heart and queen are independent. It's a short video on independence.